like. If you get those wrong, you should slap yourself. Okay.
Could I do like 2 times 19 minus 1 too?
You could, sure, if you wanted to use the alternative definition, sure. Okay, that's fine. I might ask you guys to be able to show.
But you don't need to define the definition.
No. When I say show, I'm not saying prove.
Okay.
There's a difference between show and prove.
But when
Okay.
you prove it, that's when you have to do everything.
Correct. When I say use a direct, an indirect, or an inductive proof, that's when you have to do like all those steps out. Okay. So for these 2 points, guys, if you're writing a whole proof for that, you're wrong already. Okay. So don't do that. Okay. I might ask you guys to show something like 0.9393993 is rational. Okay. And you guys remember that trick where you say x equals 0.939393, and then they say 100x is equal to 93.9393. So go back, I think it's on assignment number 4, where you guys can look and see that trick just in case you guys forgot it. Okay. I might ask you guys to show that something like 6 divides 216. So just really basic stuff, just that illustrates that you know the definitions of these sorts of things, okay? And by the way, there's a couple different ways you can do this, but what's one way that you can show that 6 divides 216?
You do front two.
Yeah, you could use long division, you could factor it, whatever you guys want to do, right? So like you could say that 216 is equal to 6 times 36, and you'd be done with that, okay? So, I mean, literally like something that easy, okay? I'm trying to think of like some of the other stuff. Like if I ask you guys to evaluate a div and mod, like if I had something like 53 div 12 and 53 mod 12, make sure you guys can evaluate those. Okay. If I have a floor and a ceiling, make sure you guys can evaluate that. So let's say I have floor of negative 9.801 plus ceiling of negative 3.001. All right, make sure you guys can evaluate something like that, your floor and ceiling functions. Those should be pretty easy for you guys.
That's negative 10 plus 3.
Yep, negative 10 plus negative 3.
Negative 3, yeah.
Right, because the ceiling of negative 3 would be negative 3. Nope, negative 3. So we're going to the ceiling, okay? What might be helpful, guys, is to draw out the number line, okay? It might sound stupid, okay, but you don't want to lose a couple points because you didn't draw out a number line. Okay. I'm trying to think of some of the other quick stuff that we've done. If I ask you guys to evaluate a series, okay, like for instance, like I think we did one like, I know we did one like this in class, like I equals 1 to 100 of like 1 over k minus 1 over k plus 1. Okay. Make sure you guys can do that without using a calculator. Isn't that one of those telescoping series where you write out the first few terms and you start canceling stuff and you end up with the first and the last term in the series? So make sure you guys are okay with something like that. Okay. If I ask you guys to do a change of variable, okay, so maybe ask you guys to write something like series I equals 3 to n of I plus 4 squared over I plus 3, using the change of variable where j equals I plus 4.
I have a question about this. When you have an n in the equation, do you change the n at all?
No, the n is completely independent of anything else. It's n dependent. Ha ha ha. That's all I got, John. It's pretty bad, isn't it? Sorry. Obviously, I can't add or multiply, so I figured I'd do that for you. That was bad too, so I'm just worthless. But that's okay. All right. Oh, go ahead, Jake.
So you add the 4 to the end, right?
Correct, right. So you would have to go through, the n wouldn't be changed, but you're correct. So you'd actually have to subtract it since j is odd. But you're right, you would still have to change the bounds, but the n would be completely independent of anything else. Okay.
When you do your J term, where do you actually get that from?
I give you that. I have to give you that. Okay, so if you make up your own j, then you're wrong. Sorry.
And you see there, you solve for I, and make your J minus 4
Yeah.
and then do
Yep,
the rest.
that's exactly right. Okay. Let me see, what else? If I give you guys a sequence, make sure you can write the explicit form of that sequence. So if I give you guys something like 1, comma, -4, comma, 7, comma, -11, comma, 14, well, wait, that one wouldn't work, would it? That one you would just say, I can't do that one. This one you can do that, sorry. Okay, so make sure that you guys can write that. If I was to ask you guys to write that as a sequence, okay, in the explicit form, all right, wouldn't you have to use that, like, that -1 to the n to be able to get the alternating factor, or the n plus 1? So maybe somebody could just look at that and tell me what they think or what they know that sequence would look like. So, go ahead.
Minus 1 to the n plus 1, 3 to n plus 1, and then n is greater than or equal to 0.
John, I think,
Or no,
For
it's
that
not just
one.
n, you just do n now.
right, you would have to use n for that one. That's okay, but you would, and I like what you did there. You just tried it, and if it didn't work, you just change the n plus 1. Yeah. So literally, all I'm going to ask you guys to do is take this sequence, write it into the explicit form. Okay? So nice and easy, right, guys? We've done that one before. We should also say n is an integer. If you forgot that, I wouldn't mind that much. Okay? I might ask you guys to be able to simplify a factorial expression. So if I gave you guys something like n plus 1 fact over n minus 1 fact, make sure you guys can simplify that. Okay, so stuff like that. Okay, nothing any more difficult or easy than what we've done already in class. Okay, so like I said, I'll give you guys like 10 of those types. Okay, make sure you guys are okay with that stuff, and that should be an easy 18 points for you guys. Okay, now where you guys probably want to focus most of your attention on is the study with the proofs. Okay, so essentially with the proofs, what I'm going to do is, like I said, I'm just going to have 6 proofs for you guys. 2 of them will be worth 10 points, and then the other 4 will be worth 15 points each. Which means what? 2 of them are easy, and 4 of them are harder. So, but just to give you guys an idea of what I'm asking for, so part 2, we're going to have 6 proofs. Okay. So, proofs 1 and 2, they'll be worth 10 points each. And essentially what they're going to be is they're either going to be even, odd, perfect square, rational, or divisibility. Okay, so I'll pick 2 out of those 4. Okay, so it'll either be like an even and odd one. Okay, perfect square, rational, or divisibility. So basically, guys, if you look at assignment number 4, okay, that would be a good reflection of what I'd ask you guys to be able to know for that. Okay, so go back to assignment number 4. Okay. And you guys should have that one back. All right, so make sure you take a look at that. If you have some questions for me before that, email me so that way I can have it. Did I post the solutions? I hope I did by now. I probably didn't, so I'll make sure I do that. All right. For problems 3 and 4, okay, for these, I'll give you guys one with division into cases, and then I'll give you guys one that's an indirect proof. Okay, so you guys know you're going to get division into cases. Okay. And then an indirect proof.
These also 10 points each.
No, these are 15 each, okay, because they're a little bit harder, so.
Are you going to tell that use division into cases on the exam?
Yep, I will say use division into cases to prove blah, 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 blah.
And which one of the indirect proof?
One more time?
Which one of the indirect proof? Which one?
Well, it's either contradiction or contraposition.
Okay.
So with indirect proof, either contradiction or contraposition. Now, which one's harder, contradiction or contraposition? So which one do you think I'm going to give you? You're correct. Okay? So, for the division into cases, I mean, really, what's the only cases we've really used?
Even
and odd. I'm sure you guys don't want the quotient remainder theorem on there. Does anybody want the quotient remainder theorem proofs on there? No, okay, so I will not put that on there unless somebody really wants it on there, but I doubt it, okay? So division into
Yeah, no,
cases.
it's difficult, but it's a long.
What's that?
Quotient remember is not difficult, but it's long.
I don't know, some people didn't like it too much, so, you know, I'll keep it off of there. Quite honestly, even in odd cases are fairly easy, okay? So if you guys want some examples of this, just go back to assignment 5.
So you're basically saying question 3 is division into cases and question 4 is indirectly.
I'm indirectly saying that, yes, sir. Okay?
Are you also indirectly implying it would probably be a constriction?
I am also indirectly saying that it will most likely, in fact, 99.99999%, unless everybody in this class emails me and says, I want contraposition. So that's probably the only way I would do that. Okay? All right, other questions, guys? Okay, John?
For cases, when it says like to prove something has either one form or the other, if it's never like one of the forms, then it's still okay because it's saying if it's one or the other.
It has to fit one of those two forms. If it doesn't, then you just disproved it.
Yeah, but it only has to fit at least one. It doesn't
Correct,
fit
right.
both.
So it would either fit 3K or 3K plus 1. It can't fit both. Okay, there's no way it can fit both.
Oh,
of them.
it just can't fit.
It cannot. There is no way that the
Oh.
number can fit both forms. Okay? That's sort of like saying a number is both even and odd. It can't be. Okay? Alright. And then guys, the last two, problems 6 and 5 and 6. Okay, those will be induction. Yay! Yeah, everybody loves induction. Okay? You guys know you're going to get one with the sequences and series on there. Okay, so one with a series. Okay. And then either divisibility or inequality. Although, if you weren't brain dead today, all right, if I had a choice between divisibility and inequality, which one would I give you?
Divisibility.
Divisibility. How come?
It's easier.
Because didn't I just say hint, like 17 times I said hint, know this? So, I mean, but I don't know what else I could do to say it's going to be on there, except that it's going to be on there.
So you're not gonna do inequality.
What's that?
So you're not gonna do inequality. You don't
Well, I can only give you two, and I've already
You don't have
said,
to focus.
let's use division into cases. I've already said I
I'm not even
will,
gonna look at it then.
I mean, you have to look at it some
Well,
point.
yeah, sure.
Okay? So, to be able to do assignment number 7. Okay, so, no,
Three, 6?
so, these two would be 10, these two would be 15 each, and these two would be 15 each, okay? So 20, 30, and 30 is usually 80, but then again, I'm not good with multiplication and addition apparently. So, everybody knows what to expect, guys. Any questions about what's going to be on there, except for the questions themselves? I mean, literally, that's probably all I can give you at this point. Okay, so make sure you guys study, okay, like, as I've said this many, many times, I've seen a lot of students go from an A to a C or a D just because they didn't take the test seriously, so be sure you guys are okay with that, so, Adam, and then, go ahead.
So the note card will.
Yeah, note card's still the
Have the
same,
same.
okay, so 3x5 note card, both sides, okay? Put whatever you want on there, don't use it if you don't want to, don't care, okay?
I got one thing,
Yeah.